So now that we've tried a percent problem that is increasing, we are going to now try one that is decreasing. So the price of this tent was decreased by 15% and sold for $76.49. What was the original price of the tent in dollars? All right, so let's take a closer look sentence by sentence. So we know that the price of the tent was decreased by 15%. So because it's not saying specifically that it is 15%, it's not going to be our specific percentage that goes into the equation. And we're going to come back to it in a bit and talk about a similar process that we did in the first problem. So let's hold on to that. The tent then sold for $76.49, right? After the decrease, it now is on a discount for $76.49. So it could be a part or it could be a total. But again, we need to do some more investigating to know for sure. And the question is asking, what was the original price of the tent in dollars? So it also is looking for the original price or that starting price. So again, this could be the total or the part. So we're going to draw out double number lines to find out for sure. So we have two parts. We have an original amount of this tent, and then we have the new number line of this tent. And let's keep both the same length for now. So that's about the same length. And so the original tent was from $0 to some amount that we're not sure. But we do know that that would represent 100% of the price of the tent. Now, when we look at the new, or the number line for the new total, we see that, again, it goes from 0, but then it's decreasing by 15%. So it's actually less than the original price. So here it is $76.49, and that's a difference of 15%. Okay, so again, if this entire number line represents 100%, and this piece here is the 15% decrease, how can we figure out the percentage that 76.49 actually represents? Well, in the last problem, when it was increasing, we had to add it to 100%. Now that we are decreasing, we need to subtract it from 100%. So let's go ahead and borrow. And I see that this represents 85% of the original total. So let's add that to our number line, 85%. And so we are going to look back at the question and see that if it is decreasing by 15%, then we are actually using 85% here for our equation. Okay, so then remembering that 85% of the original price, so percent of is cluing us in for the total. So 85% of the original. Therefore, the original is the total that we are looking for. And if it is now 76.49, then that is the part that they have given us. So let's label that. Q is 76.49, and the whole is the question mark that we are missing. Okay, so once again, let's use our equation. Quantity equals percent times whole. And we have 76.49 equals, remembering to use Dr. P to convert our percent to a decimal. So that's 0.85 times the whole amount. Since we don't know what the whole amount is, we need to divide using bow ties. So we have 0.85 and 76.49, but we never divide by decimals. So let's move it over 2 times, which gets us 85 into 76.49, getting ready to draw out our seats. And so 85 goes into 7 0 times and 76 0 times, but how many times does it go into 764? And I see that that is 8, because 85 times 8 is 680. Remembering to borrow. And now we have 849, and 85 goes into 849 9 times, because 85 times 9 is 765. Remembering to borrow one more time. Let's add our decimal and a 0. Decimal and a seat. And 85 goes into 840 9 times again, which is 765. 5, 7, 7. Bringing down our 0. And 750 divided by 85 is 8 times. So we're going to stop there. So our whole amount is 89.98. So if we look back at our question, what is the question actually asking us to find? What was the original price of the tent in dollars? So the original price was $89.98. Alrighty, so let's see. That percent problems can sometimes be difficult to determine the part total and percent. So we can use double number lines to help visualize what the problem is giving us, so we can then use our percent equation to solve. The last stamp is that when we are increasing by a percentage, we add it to 100%. And when we are decreasing by a percentage, we then need to subtract it from 100%. We're going to try some more challenging percent problems independently.